Okay, thanks. All right. Hi everyone. Good day, and welcome to this edition of our Tech Talk series. So, if you have watched our previous Tech Talk, so we've been talking about how you can automate and manage your Exadata database service. So, previous sessions we talk about how you can use Terraform, and then we talk a lot about on in introducing those ready landing zones that you can use with Exadata database service. So for today, what we're going to talk about is still how you will automate and manage your Exadata database service, but using CLIs, APIs, and SDKs. So, good day. My name is Leo Alvarado. I'm your host for today, and with me is my co-host, Sheena Argarwal. Hi, Sheena.
Hi, Leo.
Thanks for joining the Tech Talk. So both Sheena and I were part of the product management team for database cloud services and multi-cloud. And since we'll be talking about automation. So did you know that you can programmatically manage your Oracle database cloud services using these powerful tools like CLI, REST APIs, and SDK. So prefer done if you prefer to do like custom tooling or build your own scripting, then we will be covering that for today's session. And OCI, it provides us a wide choice of management interfaces that you can use with your database cloud services and specific to Exadata database service. And that the Oracle database cloud service give you a lot of flexibility in how you manage your environments. For example, if you want automation or integration with your existing tools, REST APIs are available for almost all of the management tasks. And for developers, there are SDKs in popular programming languages that you can integrate with database operations directly into your application. And if you prefer scripting, then we also have a command line interface, which we call the OCI CLI, which will be going through um, in a bit for today. So we will be covering the different interfaces. So I'll start with the OCI CLI. So let's take a look on at the OCI command line interface, or known as OCI CLI. The OCI CLI, it extends the OCI console's functionality that enable data engineers and developers to automate tasks through scripting programmatically. And to use OCI CLI, for example, with your Exadata database service. So you can install OCI CLI on your preferred client, like OCI CLI supported on Linux, Mac OS, and Windows. Or you can also use the OCI CLI via the Cloud Shell, which is a web browser based terminal from your OCI console. So you can simply launch the OCI Cloud Shell, and that comes with the OCI CLI pre-installed. Or you can also go to Marketplace and download the Oracle Linux Cloud developer image, which also comes with a pre-built OCI CLI installed. And when using OCI CLI, so almost all of the operations that can be performed from the console can also be performed from your OCI CLI, as it supports several operations for Exadata database service specific to database deployment and database lifecycle management. So some of the operations, like if you wanted to manage maintenance and updates operations, manage your database backups and recovery, or specific to your Exadata Cloud VM cluster, like managing SSH keys, changing licensing models, or if you wanted to create a script that will list the VM cluster updates and upgrades, or a script to perform pre-check and apply VM cluster updates and upgrades. So you can also use the OCI CLI. Same also with your database and database forms. Like you can use CLI to create, delete, start, stop, and reboot, enable and configure automatic backups, manage your database, backup and restores, and also even performing pre-check and apply database updates and upgrades. And getting started with OCI CLI, it's very easy to get started with OCI CLI. So I'll let Sheena just walk us through, like, Sheena, like how if I would like to get started with OCI CLI, like how would I even install OCI CLI on a client?
It's pretty straightforward. So you just follow the CLI installation guide. You on this guide you'll be able to see how to install the CLI. So it starts with running the installer script. We have the installer scripts for all the environments. So you can just go to the environment that you want to run it on and then just run this installer script that you have. Then you follow the installation script prompts. It'll just give you basic yes no questions. And then you run the OCI setup config. All of these are also part of the installation guide here in point one. We'll also link it in the description that we'll share with you after the end of this session. And yeah, so you basically just set up the config as it is given here. You generate the API key pair, create a configuration file, and then just upload the public key using the console. And you verify the configuration file, and you're good to go.
Wow, that is so simple and easy.
Yeah,
So
it really
yeah,
just takes 5 minutes to do all.
yeah. And for this generate API key pair for their credentials, where they can get this API keys?
Right. Let me share my screen and show you how to. Right. So when we go to the installation guide, this is the installation guide, and you should be able to see, just find your specific environment that you want to install it in. Let's say I want to install it on Mac. I just do a brew install of the OCI CLI. And then after that, I just follow the installation script prompts. I set up my configuration file using the OCI setup config, which is what we just looked at in the PPT also. And then we also mention here how to get the required keys in OSIDs,
Mhm.
where to get the tenancies OSID and user OSID, and how to get the region and availability domain.
So
And then,
for the credentials, like the required keys and OSID, so these are all can be obtained from the console, right?
yes, from your cloud tenancy, if you just sign into your console, you should be able to get all of these. You can also go to this link quickly and see how to get it. So if you just go to this, you should be able to simply generate your API signing key using the prompts here. And once you go sign into your cloud environment, just go to the profile user settings and you should be able to get the values from there. And then you can just upload and paste your key that you generated in the previous step.
Mm. And this credentials will be used as the a user for running the OCI CLI from
Right. So whenever we run any commands from the OCI CLI, when once you create this directory and put your values into the file for this, your OCI CLI is going to connect using the default profile that we've specified here. We can actually specify that profile. So when you go to the quick start guide, just below that, if you go to using the CLI, and go here, or rather configuring the CLI, you should be able to specify which profile I want to use for my OCI CLI settings.
Mm. And then let's say if I'm building a script and I wanted to attach it to a service account. So that service account that I created in my OCI, that's the profile that I'm going to use to obtain all these credentials, right?
Right. So we can have multiple profiles in my OCI config.
Mm-hmm.
Let's say you want to connect to multiple compartments, or rather multiple regions or multiple tenancies. You can just have all of those profiles in your same OCI config, have different profile names for those, and then just specify which profile we are connecting to while connecting from your OCI CLI.
Nice. That's great. And in addition to what Sheena have shared, so if you're also interested on the looking at the different commands of using OCI CLI, so for database cloud services, you can find all the commands there parked under the DB section. So going through the OCI CLI documentation. So you just need to go to the DB section, and then you'll find all the available commands for database cloud services. And then specific to Exadata database service, so you just need to check what type of resource that you wanted to get the OCI CLI commands. So that's how you configure OCI CLI. Now maybe let's have a look on some of the examples, and maybe we can also have a look into the some of the syntax examples for the different lifecycle common lifecycle management that you perform with your Exadata database service. So here is an example for, let's say I just wanted to list down all my available cloud VM cluster. So the syntax is pretty straightforward. So it's OCI. DB is the service, as what I've shown you a while ago, and then the resource type is the cloud dash VM dash cluster, and then you have an action of a list. And since we wanted to list all the VM cluster available from a specified compartment, then you can use the argument option of dash compartment dash ID, and you just need to provide the compartment OSID. And once you run that command, so you'll see here a sample output, and you can also make use of the query options in addition to your CLI syntax. So here I'm just trying to take the some of the specific data from the output. Like I just wanted to display the available VM cluster, show me the VM cluster name, what's its VM cluster OSID, and then the grid infrastructure version. Okay. And you can also make use of CLI to, if you want to list or display what are those available updates that I can apply to my VM cluster. So the syntax is pretty straightforward. It's just OCI DB cloud VM cluster list updates. So the action is list updates, and I just provided the my VM cluster OSID for that argument dash dash cloud dash VM dash cluster dash ID. And here in the in the output, I can easily show and list down the available updates that I can apply to my VM cluster sorted out by update type. So I can see here the available updates, like for my OS update and grid infra update. And more examples, like if you wanted to scale up resources, so you can also use CLI. So this is a example on scaling your the OCP of your VM cluster. So the command, so you have a command here, cloud VM cluster update, and we just provided the argument of the dash dash CPU dash core count, and then just provide the new OCPU count. So if you want to scale up your VM cluster. So you can create a script for scaling up and scaling down your VM cluster using this CLI command. Same as if you wanted to create a custom database software image. So let's say you wanted to standardize on a particular RUs for an environment for a database. So when you create a database home, you can use the Oracle provided images or make use of your own custom database software image. In OCI CLI, there's a command database software image create that lets you create a custom database software image, and that you just need to provide the database version, the patch set, and then the your compartment OSID. And then you'll see here an argument image shape family. So if you are creating a custom database software for Exadata database service, then you need to supply the Exadata shape for the image shape family. Once you have created the custom database software image, you can create an Oracle database home out of that custom database software image. In CLI, here's the command to create a database home. It's just db home and then create. And then you just need to supply the arguments. Like if it's creating from a custom database software image, so you'll see there the argument database dash software dash image dash ID. So that will be the database software image OSID of the custom database software image that you have created previously. And then you just need to specify the VM cluster ID, which is your VM cluster OSID, and then you need to provide the database version. Same thing with creating container database. In CLI, there's a database create command, and that you just need to provide the required arguments, such as the admin password, of course, the database name, and then the VM cluster ID. You need to provide which VM cluster you wanted to create your CDB. So you just need to provide the VM cluster OSID. And once you create the CDB, you can also create pluggable database using CLI. So same thing. So as you've seen here, whatever you see in the console, you can also provide it as an argument and options for the CLI command. And when it comes to updating databases or updating your database home, like there's also a CLI for you to. So here in this example, we're just listing the available updates that I can apply for my database home. So you just need to use the CLI command of patch list db home, and you just need to provide the db home ID or the database home OSID to check what will be the available patches or updates for that database home. So in the output, so you'll see here the description, the patch ID, which is the OSID of the updates, and then the version. And once you've listed down the available updates, let's say you wanted to apply that particular patch or updates to your database home. In CLI, there's also a command of db home update. Again, you just need to provide the OSID of your of the target database home that you wanted to update. And here, there's an argument dash db dash version. So it's a complex type of an argument. So if you see in documentation, complex type, so this must be a valid JSON file. So for this example, like here, the db version, it's a passing a JSON file, and that JSON file, it contains an action. So an action, it could be what will be the update action that you want to perform. So it could be either pre-check or apply, and then the patch ID corresponds to the patch OSID that you just have uh, obtained when you're listing down the available updates. So once you have that JSON file prepared, then you can just use the CLI command for db home update, and then for the db version, you just need to supply this JSON file, and here for this example, we're just doing a pre-check for that specific update. So after you run this, so you'll see here in the output that the lifecycle state changed to updating, meaning it's now started to apply the updates. I mean, to run a pre-check for that updates for that database home. Enable automatic backup. So when you create a database. So the enabling automatic backups, it can be done either through the provisioning of your CDB or after creating your CDB. So here you can also use CLI to enable automatic backups. So for this example, I have an existing container database that I would just like to update and enable automatic backup. In CLI, you just need to run the command database update. The database ID, you just need to provide the OSID of your CDB, and then you have an argument here which auto backup enabled, and that you just need to set it to true. And then you'll see some of the additional options here, like under the backup config. So you'll see here a backup destination type, which you can also set your backup destination type to autonomous recovery service or object storage. And once you've enabled your automatic backups, you can also create a database from a backup using CLI. So there's a command database create from backup. You just need to provide the backup ID. So the backup ID, it's the backup OSID of the created backup. So so you can create a database out of that backup using this command. So those are just the common life cycle management tasks for your database that you can use and use CLI to perform. And yeah, for other management interface, so we've covered CLI. So now we go with REST API, and I'll hand it over to Sheena.
All right. So right. So we spoke about Terraform in the previous sections and about CLI. Now, this Terraform and CLI are just wrappers which eventually access the OCI REST APIs under the hood. Now, if you want a if you want a more language agnostic framework for your development and you want to use the REST APIs directly, you can just directly call them. So these APIs are they're used to access the REST APIs that directly interact with the backend resources. You can programmatically provision and manage the database deployments for the Exadata database service using these REST APIs. You can use get, post, put, or delete, the usual operations for REST APIs. And some of them are going to require JSON in the request body and return a response as JSON too, just like all REST APIs. Now, when you execute these, you should be able to also programmatically determine whether it was a successful response or not, depending on your response codes. So, just to give an example, let's say you want to list all the available updates that are available for your VM cluster using a REST API. So you can simply use a REST API called list exadb VM cluster updates. Now, this is the API call that you can make. So just to give an example, if you check here, you should be able to see the request here, right? So there's an HTTP method is the get here. We have the target URL. We have exadb clusters. We're giving the cluster ID and we're asking for the updates. Now, after that, we're also massaging the data and extracting the update type, the description, the version, and all of these fields from our response. So you should be able to see what all update types and OS updates are available for the given VM cluster. Now, just to give another example, let's say you want to list all the available DB homes in your specified compartment. So you can simply call this specific API. And if you look at this code down here, you should be able to see that we're using the HTTP method get and um, calling the DB homes with our specific compartment ID and the lifecycle state as available up to 10. And then again, we're extracting the display name, ID, lifecycle state, and DB version for all of the DB homes in our compartment. Now, like that, we have many different REST APIs that you can directly call in whichever code you're using. You can use them for monitoring and managing your Exadata database service, whether it's the infrastructure, VM cluster, DB home, container database, or pluggable database. So if you just go to this URL, you should be able to. So we'll also link this URL in the description later. We'll share it after this call. And yeah, here we have all of the REST APIs for managing the cloud infrastructure, the cloud VM cluster, the database home for managing the databases, the pluggable databases, for managing the software image, the backups, and different all other things, the data guard, anything related to Exadata. So just to give an example, let's say we go to create cloud VM cluster. You can simply go to the description for this specific REST API. Now, if you see, we've provided an example of how you can use this specific REST API directly and the success response. So this is the kind of response you should be expecting once you run your uh, the API. Now again, we obviously have some bad statuses just to see if your request did not go through for whatever reason. We've also provided how you could use this same API in your Java SDK as well as Python SDK and other language specific SDKs, right? Now, this is
And then Sheena, for each of the REST API calls, so what we have shown here is like a raw response, but again, as you also shown from your previous examples, they can easily massage it and just get what specific field or data they wanted to, right?
right. You can simply extract your data and specify which fields you want. Let's say you're interested only in the display name, ID, lifecycle state, and DB version, and not all of the fields in the response. You can simply extract it out of your response. So this is how your response looks like, right? Let's say you're interested only in the display name, lifecycle state, and ID. You can just extract the fields that you're interested in. And you can also check all of the REST APIs. If you just navigate through the navigation pane on the left, you can see all of the REST APIs for cloud Exadata infrastructure, for cloud VM cluster, for the database, the DB home, and yeah, Exadata infrastructure. So all of the REST APIs that you need are here on the left. You could just go to those and look at the API, its usage, and the parameters that are needed for the request. So we're also going to share this link with you after the call and link it in the description for the video. Now we also have an API, the REST API Postman collections. So Leo can,
Yep.
walk you
So
through
so you
these.
Yeah, so you've seen a while ago, Sheena shared the documentation. So you see all those API calls that you can do with database cloud services. Now, if you're using a client like Postman, in Postman, we have also uploaded collections for database cloud services. And if you're using Postman, so you can just fork that database services collections, and then you can just choose the whichever API calls you need for specific database cloud service. So let's say for database home, so you have a collection here where you can just pick database home, then you'll see all the get calls and post calls for your database home. So if you just scroll down a bit, Sheena, from the, yeah. So if so you can just provide your variables and parameters and use this API collection.
Right. So these are basically pre-made some Postman stuff that we've already created for you that you can simply use out of the box to test your APIs before you even put them into your SDKs or any other code that you're using to automate your Exadata infrastructure management. Right. And these are some of the examples of how you can use the REST APIs to create pluggable database. Again, this is just just an example, but you could use any of the APIs that we saw in the here in the Postman library, as well as the main library where we have all of the REST API calls that OCI provides for Exadata database service management and monitoring. Now, we spoke about how to use CLI, Terraform, and also how to directly use the REST APIs. Now, we also have some pre-configured SDKs, some language-specific SDKs that you can use to, and we have some language-specific APIs that have already been created by OCI that you can just use out of the box to facilitate the monitoring, provisioning, and development of your Exadata database service infrastructure and other things that are needed to run it. Now, these SDKs, they allow you to build and deploy apps that integrate with your OCI services. We provide them for various languages like Java, Python, TypeScript, JavaScript, and many other languages. So this is the QR code and the link where you can access the SDKs that are pre-configured. So here you should be able to access the SDK for different languages. Now let's say we go to the SDK for Python. So this is the page that tells you which all services are supported, how you can install the manager for that specific. So if you want it for Python, you just install the Python OCI SDK, right? And once that is installed, you can basically specify your config. Now this config is from the same file that we created earlier during the OCI CLI setup. And then you simply call the required API that we want to call. Where can we find these? You just scroll down and then you can go to database and just search for, let's say, you want to create an Exadata one, right? So if we want to create an Exadata cloud infrastructure, you just scroll down to the API for that. Our Python SDK already has pre-configured APIs for all of these things. So you can simply use this out of the box and that's it.
Yep. So they can easily pick and choose which methods they wanted to use for their SDKs.
Right.
Yeah.
And then, yeah, so this is an example of how you can actually use it. This is one of the APIs that we've picked out of the Python SDK. You simply provide your own admin password, DB name, and all of these things, and just use the create database details API from the SDK, and then just automate your Exadata database service, provisioning and monitoring, and whatever else we need to do for the service.
Yeah, and if they want to like customize this method, so they can just also add some of the available attributes that they can use with this method for creating a CDB and PDB.
Right. So we have all the parameters that are supported that are mentioned here, and then we can just specify which ones we want.
Yep.
Yes. So those are the few things that we discussed. In the previous sections, we talked about how we can use Terraform to automate our provisioning and monitoring of the Exadata database service resources. And then today we spoke about CLI, REST APIs, and SDK, although they're all interlinked, and CLI and Terraform are more of a wrapper over our REST APIs. And these REST APIs can also be called from our SDK. The base is basically just the REST APIs, which you could either directly call or use one of the wrappers that are already pre-created for you. If you have any questions related to this, you can ask.
Yep. And yep, and then if they're also interested on getting the links to what we have shared for today. So we also have a public Slack workspace. So our public Slack workspace, it's Exadata dash database dash service. So that's a public Slack workspace where we uploaded all our get started guides, our how to demos and GIFs. That's where we also share our Tech Talk series, like replays of this Tech Talk and also featured blogs. So how can you join the the public Slack workspace? So here's the join link. So you just need to uh, click on the join link or scan this QR code, log in using your email account for Slack, and then check your email, set up your 2FA, and that's it. So welcome to our workspace. So if you have any question, you can also reach out to that Slack workspace, and you'll also be sharing the links in the public Slack channel once we've shared the replay of this uh, TED Talk. Yeah, and if you have any additional questions, just feel free to type in the Q&A. Okay. And yeah, let's see. Okay. So there's a question on how do they get the slides? Oh yeah, it's been answered there. So we will be posting the slide links to the public Slack channel. Okay.
All right.
So if there's any questions, if there's not, then yeah. So this brings our tech talk with me and Sheena to an end. So thank you everyone for joining the tech talk, and yeah, happy holidays.
Happy holidays, everyone. Thank you.